So work package 2 is about developing quantum-enabled inertial sensors for positioning and navigation.
What we're trying to do is put together a set of quantum-enabled devices. And the idea is that in order to navigate, you kind of need to know three things. You need to know where you're starting. You need to know how fast you're moving, and you need to know what time it is. So what we're trying to do is we're working on kind of the rotating and accelerating part.
So we're developing atom interferometers that can measure accelerations and rotations, and we do that with the atoms in free fall, so in free space. But it limits the amount of time that we can probe them because they're falling under gravity. Whereas Carrie's are trapped, and so she can potentially get much longer interrogation times in the future.
So my shtick is I make atoms very, very cold, and then I poke them, and then I look at how they respond, and basically what happens after I poke them, I can then sit there and I can back out, here's how fast we were accelerating, here's how fast we were rotating. But there are various different types of devices that are basically using light to measure rotation and whatnot.
In my labs here at Imperial, we have a multi-axis laboratory sensor that can measure accelerations along multiple axes and rotations along multiple axes, and working towards getting higher performance sensors that we can run for longer. In parallel to that, we've taken the bits of apparatus from the lab that work well, and we've engineered it into a transportable system that we're now taking out into the field. So we've already taken this to sea a few times, and we've deployed it on the London Underground with Transport for London. And now we're looking towards other kind of platforms. So we're considering aviation, so airplanes as well.
The ones that I actually like are like the unmanned underwater vehicles, because then you could say, well, this could actually be used for like environmental monitoring, right? Like, it's really important to keep in mind with this sort of positioning, navigation, and timing is that it's not all related to defense, and it's not all related to making sure you can get from your home to the supermarket. Like, there are a lot of applications in that space that are really very cool and very potentially beneficial to the environment, to the world that we live in, to kind of making where we are and where we live a better place.
But I guess the next thing is to engineer the next generation of these systems that can be deployed without perhaps a team of physicists with a lot of laboratory experience in order to make this thing do what it needs to do out in the field. I think that's the next step.